Hello, welcome to Unit 6, Lesson 4, Reasoning about Equations and Tape Diagram, Part 1. The learning objectives for this lesson are you'll be able to draw a tape diagram to represent a situation where there is a known amount and several copies of an unknown amount, and explain what parts of the diagram represent. And then you will also be able to find a solution to the equation by reasoning about a tape diagram or about what value would make the equation true. So this differs from what we did in our last lesson in the sense that we are now being presented with situations. Before, we just had equations and tape diagrams. We matched the equations to the tape diagram, or we drew an tape diagram for the equation, and then we solved by reasoning it out. So today we're just taking it a step further and adding in those situations. We are going to skip the warm-up and move on to activity 2. So for this activity, you will be expected to draw a tape diagram for each of the situations below. My recommendation is start with identifying what your unknown is and then build a tape diagram around there. For question 1 and 2, it gives you variables that you can use, but question 3, 4, and 5, they don't outrightly tell you what the unknown is. So you're going to have to do a little thinking and figuring it out on your own. So you're actually going to skip number 5. I decided I don't want you to do that. So just go ahead and focus on questions 1 through 4, skip number 5. All right, let's go ahead and take a look. So question 1 says Diego has 7 packs of markers. Each pack has X markers in it. After Lynn gives him 9 more markers, he has a total of 30 markers. So right off the bat, some things I notice is that X markers, this represents our unknown. So that is helpful. It also says he has 7 packs of those unknown markers. So I know I'm going to have 7 boxes of my unknown. It says Lynn gives him 9 more markers. Now, I need to decide if that's grouped with the unknown amount or is it going to have its own little square. So I have to think about it. Is each pack getting 9 more markers, or is he just getting 9 altogether? And he's just getting 9 altogether. So I know 9 is going to be in its own separate box. I also see that he has a total of 30 markers, so I know that my tape diagram is going to be the length of 30. So I'm going to go ahead and draw that. So first thing I do is I'm going to put the 9 in its own box, and then I want to draw 7 boxes. X in each of those boxes. And then I have my total, let's redo that, of 30. So that is what your tape diagram should look like. Let's look at number 2. Elena is cutting a 30-foot piece of ribbon for a craft project. She cuts off 7 feet and then cuts the remaining piece into 9 equal lengths of X feet. So I know, first of all, right off the bat, that this 30 feet, that represents the total length of the ribbon, which is also going to be our total for our tape diagram. I'm going to switch colors. So I know the tape diagram is going to be 30 feet long, not really 30 feet, but it represents 30 feet. It says she cuts off 7 feet. So I know that you want to think of this as subtraction, so you may think, oh, -7. But if we're thinking about the ribbon just being the whole tape diagram, it's just telling us that one section of that tape diagram is going to be 7 feet. So this is going to be in its own little box. And then it cuts the remaining pieces into 9 equal lengths of X feet each. So again, we have our unknown, which is helpful. So I'm going to go ahead, draw my tape diagram. First, I know I have a section of 7, and then I need 9 boxes. And each of the boxes should be X. And then finally, I have my total, which is 30. Okay, let's look at the next one. A construction manager weighs a bundle of 9 identical bricks and a 7-pound concrete block. The bundle weighs 30 pounds. So what I don't know here is the weight of each brick. So my unknown, I'm going to go ahead and write that down, is going to be the weight of each brick. So I'm going to just use X to represent that, just to go with the theme. You can use whatever variable you want though. I do know I have a 7-pound concrete block, which is separate from the bricks. And I know that the total weight is 30 pounds, so that's my total. So if I draw my tape diagram, I'm going to mark off the 7 for the concrete block, and then I need 9 more boxes to represent the bricks. So each of those are 8. And then again, that is going to be equal to 30. Okay, let's go on to number 4. So it says a skating rink charges a group rate of $9 plus a fee to rent each pair of skates. A family rents 7 pairs of skates and pays a total of $30. All right, so for this one, first of all, it tells us we have a group rate of $9. So this tells me I'm just going to pay one price for the entire group. It's not per person, it's for the entire group. I do not know how much it costs to rent each pair of skates. So I'm going to do unknown cost to rent skates. And again, I'm going to stick with X just because that's what we've been doing. It says they rent 7 pairs of skates, so I'm going to have 7 of those boxes of my unknown. And then again, I have my total of 30. So I'm going to draw my box. First box has a 9 in it. The rest have X. And that's a total of 30. All right, so just a few things to think about for the situations where we didn't have an X, so questions 3 and 4. How do you decide what quantity to represent with a variable? So it's really important that you think about what's unknown. That's why I always say identify the unknown first. So although there are some unknowns, they still have a relationship to one or more of the other amounts in the story. So in question 3, we had an unknown of the weight of each brick, but it was connected to the 9 because there was 9 of them. In question 4, we didn't know the price of the cost per skate, but it was connected to 7 because we know there were 7 pairs of them. Also, you may have noticed that some of the situations had the same diagram. If we were just looking at the situations, hopefully you picked up on that earlier. So you're looking at the situations that have the same equal number of parts, the same amount for unequal parts, maybe the same amount for the total, the same number of unknowns, and things like that. So that's it for this activity. Let's move on to the next one. For this activity, you are presented with 3 different equations. What you need to do is first read the situation and find the equation that matches it. From there, you're going to find the solution to the equations, maybe think back to those tape diagrams to help you because they are the same equations from the previous activity. And then also explain what does each solution tell you about the situation. We are going to cross off the last equation, so you can go ahead and cross that off. And you will also not be doing the very last one. So the one about the brownie pans, we're going to cross that off as well. So you're just doing A, B, C, and D, equation, solution, and talk about what it represents, go ahead, pause the video, and work on that. All right, let's take a look at A. Diego has 7 packs of markers. Each pack has X markers in it. After Lynn gives him 9 more markers, he has a total of 30 markers. So that you'll hopefully recognize that this is the same situation that we saw in the previous activity, and we did have a tape diagram to go with that. So let's go back up there and just take a look and see what that tape diagram looked like. So the tape diagram showed 7 X's and then a number 9, and then it was all total to 30. So I know if I have 7 X's, I need to write that as 7X. So that's 7X. Then I had the plus 9 equal to 30. For my solution, I am going to first subtract 9 from 30 to give me 21, and then do 21 divided by 7 to get 3. So this 3 tells us that each pack of markers had 3 in there. All right, let's look at letter B. Elena is cutting a 30-foot piece of ribbon for the craft project. She cuts off 7 feet, then cuts the remaining piece into 9 equal lengths of X feet each. So we look at the tape diagram. We see that we have 9 equal sections of X and then a 7, and then the whole tape diagram is made up of 30. So I would write that as 9X plus 7 equals 30. To solve this, I am going to first do 30 minus 7, which is 23, and then 23 divided by 9. You could say either 2 5/9 or 2.6 is also acceptable. So this represents each of the remaining pieces of ribbon are 2.6 feet. Okay, let's look at C. So this one was about the bricks. So a construction manager weighs a bundle of 9 identical bricks and a 7-pound concrete block. The bundle weighs a total of 30 pounds. So without using the tape diagram this time, I'm going to go ahead and create the equation. So if I have 9 identical bricks, that's 9x, and then an additional 7 pounds, and that's going to be equal to 30. So just like the previous problem, we're going to do 30 minus 7, which is 23. 23 divided by 9, which again you can have as 2 5/9, or 2.6 is fine as well. So this time it represents the weight of each brick is 2.6 pounds. Last one is about the skating rink. So the skating rink charges a group rate of $9 plus a fee to rent each pair of skates. A family rents 7 pairs of skates and pays a total of $30. So this time I have my 7X to represent the 7 pairs of skates plus the family fee of $9, and that is equal to 30. To solve, we do 30 minus 9, which is 21. 21 divided by 7, which is 3. So we would say each pair of skates costs $3 to rent. All right, so let's look at one of the examples on the summary. So in question 1, it says an architect is drafting plans for a new supermarket. There will be a space 144 inches long for rows of nested shopping carts. First cart is 34 inches long, and each nested cart adds an additional 10 inches. The architect wants to know how many shopping carts will fit in a row. So if we think about this situation, the unknown for the situation would be, well, how many carts can we fit in the row? So we could use our variable to represent that. Could be C for carts, X, Y, whatever you want it to be. What we do know is that the first cart is 34 inches. So I'm going to represent that 34 is just a plus 34. And then after that, we have each additional cart, which adds another 10. So it's going to be 10 times the additional number of carts, and that is set equal to 144 inches. So when you guys are thinking about your situations with your equations, really try to remember to ask yourself, first of all, what is my unknown? What am I trying to figure out? Ask yourself, what are the important numbers that I need in the equation? And what operation am I going to be using? So think of those key terms that we've talked about in the past that represent each type of operation. The other thing I want to talk about is this word solution. So when we ask what is the solution to the equation, we're not asking like what is the total, right? So in this case, the total would be 144 inches. We're asking what is the answer to the unknown. So what is the unknown? So just keep in mind you're not confusing what that word solution means. So that's it for today's lesson. Make sure you submit this 4 points, and don't forget to complete your homework tonight. Have a great day. Thanks for watching.